Sample problem. Shown on the figure is an RC circuit with the given values. The circuit has been running on for a long time, so that means the capacitors are fully charged and there is no current flowing in these capacitors. For letter A, what is the total capacitance of the circuit? For letter B, what is the current through the 10 ohm resistor? For letter C, what is the potential difference between CD points? For letter D, what is the charge stored on the 6 microfarad capacitor? For letter E, what is the potential difference for each capacitor? For letter A, the total capacitance for capacitors connected in series is done using equation 5. We see that the total capacitance is 4 microfarad. For B, the current through the 10 ohm resistor is done using equation 22. The circuit tells us that the resistors 1 and 2 are in series connection with the voltage source, so their current will be the same. We need to determine the total resistance so that we can use the EMF source to find I. The resistors are in series, so we use equation 15, which is 30 ohms. We then substitute this back and the equivalent current is 0.2 amperes. This is also the current through the resistor 1 and 2. For letter C, the potential difference between CD points is connected to the EMF source and the resistor 2 in parallel connection, which means that the voltage difference between C and D is the same as the voltage difference between E and F. So we find the first voltage difference for resistor 2 using equation 22, which gives us 4 volts. This is also the voltage across points C and D where the capacitors are. For letter D, the charge stored on the 6 microfarad capacitor is the same as the charge at the 12 microfarad since they are connected in series, which is given in equation 10. So we can determine the charge by using equation 1, where we utilize the equivalent charge, equivalent capacitance and equivalent voltage which we have obtained earlier. The equivalent charge gives us 16 microcoulomb. For letter E, the potential difference for each capacitor is done using equation 1. We then manipulate the equation to accommodate the condition for capacitors connected in series, which is dependent on the capacitance value. For capacitor 1 we see that it is about 1.33 volts and for capacitor 2 it is about 2.67 volts. When we sum these two voltage, it would give us 4 volts, which is equal to the voltage across points C and D which we have solved earlier.